Hello friends, today I'm going to discuss motion on a pulley system in physics. So that's under linked acceleration. So first of all, I'm going to look at this question. The question says a light inextensible string passes over a smooth pulley and carries masses of 4 kg and 3 kg at its ends. The masses are released from rest. The question says we should find their common acceleration, I, their speed after 2 seconds, and I, the distance traveled at that time. First of all, the question says that the pulley is smooth, so I'm going to draw the pulley system for me to enable me find a formula that we use to solve, get their common acceleration. Now, this light inextensible string passes over this pulley. Assuming that this is the pulley system. Okay, I'm going to label pulley here. So now this light inextensible string passes over the pulley system in this fashion. Okay. Now, assuming that and carries these masses 4 kg and 3 kg at its ends, maybe it's carrying 4 kg here, 4 kg here, and it's carrying 3 kg here. It's carrying 3 kg here. Okay. These are the two masses at its end. So now remember that this pulley is smooth. So this is going to exert because this is going to be this 4 kg mass will be trying to drag 3 kg mass, and the same 3 kg mass will be trying to drag 4 kg mass. Now, as a result of that, I'm going to exert tension here and here. So if I label tension T and also label tension T here, now remember that this is going to be acting downwards, trying to pull 3 kg up. 3 kg will still be acting downwards, trying to pull 4 kg than when they are released from rest. Okay, now what I need to do, remember that from the Newton's second law that F is equal to ma, because they say we should find their common acceleration. Now I'm going to use this F, or weight, is equal to mass times acceleration. But before that, I'm going to get, for the 4 kg mass, I'm going to get the net weight acting downward. The net weight is going to be, remember that 4 kg is greater than 3 kg. So the net weight is going to be mg minus the tension on the string equal to ma. So this mg minus t, let's assume is equal to F. That is or W. If you use W is equal to ma. Remember, force and weight are the same. So now the net weight acting downward is going to be this. Now I'm going to use this to look for, because tension is not given, we don't know the tension. Now remember that acceleration due to gravity is given as 10 meter per second square. This is actually meter per second square. Now, and mass is 4. I'm going to write 4 times 10, which is 40. 4 times 10, because G is 10, so it's going to give me 40. That is the weight, okay, the actual weight, minus tension, okay, that will give us the net weight of 4 kg acting downward, trying to pull 3 kg up, is equal to 4 times acceleration. So I may just call this equation 1. I'm going to work out equation 2, okay, because these are two masses are actually involved. So the same, I'm going to do the same here. But remember that this 4 kg is greater than 3 kg. 4 kg, we're trying to drag 3 kg up, okay, making the tension here greater than 3 kg. The tension is actually greater than 3 kg. So now that is going to be, to get the net weight of 3 kg acting downward, it's going to now, it's not going to be mg minus t, rather it will be t minus mg, because tension is going to be greater than 3 kg. That is why this 4 kg is going to pull this 3 kg up, because it's actually a greater mass. So it's equal to ma. So I'm going to write tension we don't know minus 3 kg times acceleration due to gravity, which is a 10. That is going to give me 30, is equal to 3a. So I have equation 2. So what I need to do, I'll add equation 1 to 2. So that's what I'm going to do for me to solve, because this is actually simultaneous equations. So I'm going to add the two, equation 1 to equation 2, to eliminate the tension, because we're not looking for the tension. We're actually looking for the acceleration, their common acceleration. So this is going to be, I would say, 40 minus tension plus, that is this equation 1, plus t minus 30. I'm using elimination method now, is equal to 4a plus 3a. 4a plus 3a. Now, this is 40 minus 30, because they are like 10. That's going to give me 10. Okay, this is minus t plus t, which is the same thing as t minus t, which will give me 0. So this will be eliminated. Tension will be eliminated. So is equal to 4a plus 3a. That is going to give me 7a. Now, this is the first one. Their common acceleration is going to be, making a the subject of the formula, is going to be a is equal to 10 divided by 7. That will be 1 point, if you press calculator, 1.43 meter per second square. Remember, we are dealing with acceleration. Is SI unit is meter per second square. Now, the second one, the question says the distance, the speed after 2 seconds. And now, remember, I'm going to use the first equation of motion, which is v is equal to u plus at. Then u is the initial velocity, v is the final velocity, that's the velocity after 2 seconds. Then a is acceleration, t is the time, that is the 2 seconds. And remember that the masses are actually released from rest. And remember, in motion, when a body is released from rest, the initial velocity is always equal to 0. So this is going to be v after 2 seconds will be equal to initial velocity is 0 plus acceleration, we got it as 1.43. 1.43 multiplied by time, 2 seconds. That is this 2 seconds. 2. So that is going to give me v is equal to 2 times 3 is actually 6. 2 times 4 is 8 point. 2 times 1 is 2. So velocity is 2.86 meter per second. Remember, velocity is measured in meter per second. That's displacement over time. Now, I'm going to look for the third one, which is the distance traveled at that time. So distance travel, I'm going to consider a third equation of motion, which is x is equal to ut plus half at square. Now, in my next topic, we're going to discuss this equation of uniformly accelerated motion in details, so you know how to use them. Now, this is what we're going to use, because x represents the distance covered, then u is the initial velocity, which I've told you before. Now, time plus half acceleration times t squared. So x is going to be 0, u is 0. 0 times time is 2 plus half acceleration, we got it as 1.43 times 2 raised to the power of 2. Time is 2. So this is going to be distance covered will be equal to 0 times 2 is 0 plus 2 raised to the power of 2 is 4. And remember, this is half. Half of 4 is 2. So 2 times 1.43 is going to give me 2.86. So 0 plus 2.86 will be equal to 2.86 meters. Remember, we're dealing with distance. It's measured in meters. Okay, so this is the way to go about this question. Now, if you like this, just don't forget to subscribe to my channel, make a suggestion. Thank you.